Now we talk about the broadcasting rules. You are able to add a scalar like 5 to a vector. In this case, we're looking at a row vector. So it has only one row and multiple columns. Here, there are 3 columns, and A range stands for array range. And then it gives you an array that starts at 0, stops one short of 3, so it's 0, 1, 2. So you're able to add a scalar to this because it's going to broadcast the scalar. Basically, it makes the scalar the same size as the array. So it's going to be a vector of 5, 5, and 5. So it will also be a 1 by 3 array. So 0, 1, 2 ends up being added to 5, 5, and 5. And it's basically an element-wise addition of 5 to each item here. And that gives you 5, 6, 7. Here we have ones, and it's 3 by 3. So the shape is provided as a tuple, which is the argument to the ones function. So this will give you ones, right? 3 by 3 ones. And that's what this is. 3 rows, 3 columns, all filled with ones. And then you are adding a range 3, which is 0, 1, 2 from the previous line. So how do you add a 1 by 3 array to a 3 by 3 array? You broadcast the 1 by 3 array. Basically, you repeat it. And in this case, you repeat it twice. So it becomes 0, 1, 2, 0, 1, 2, 0, 1, 2, like so. And then you do element-wise addition. 1 gets added to 0, 1 gets added to this one gets added to this 2. And you obtain the results shown here. You are also able to add a 3 by 1. That's what this reshape does. A 3 by 1 vector, like so. So that's a column vector, gets added to a 1 by 3 array, which is a row vector. And what it does is to replicate this 0, 1, 2 2 more times. So it becomes 3 by 3, like so. And then it replicates this one downwards 2 more times. It becomes 0, 1, 2. And then you do the element-wise addition, and you obtain the array shown here. If there is no match whatsoever, in this case, you're adding 3 by 2 to 1 by 3. And then that addition is not possible because it doesn't know how to broadcast the vector so that they are of the same, or so that they are of compatible size. Now we move on here. A ranges will be 0, 1, 2, right? And A will be an array. We can print the array. B is a scalar, and then we do the addition, which is basically the first thing here. So basically the next couple of cells will be doing these 3 calculations one at a time. So 0, 1, 2 gets added to 5. It's element-wise, so it's 5 added to 2, 5 added to 0, 5 added to 1, 5 added to 2, and you get 5, 6, 7. Here it's A range 0, 1, 2, right? And that's 1 row, 3 columns. We reshape it so that it has only 1 column. So it becomes 3 rows, 1 column. It's reshaped from being a column vector to a row vector, like so. So this is precisely what you're looking at. You get a column vector from A range by default. You get a row vector from A range 3 by default, and then you reshape it. We specify 1 column, and then we do -1 for the number of rows, and it figures out there are 3 items in the row, so it's going to have to be 3 rows. So that's what's going on here. We can print it is 0, 1, 2 in column vector. B is 5, and then you can add it, get the same result element-wise, except this is a column vector, the other was a row vector. NumPy.ones, so 3 by 3 filled with ones. And then this is 0, 1, 2 as a row or a column. Which one is it? By default, it's going to be 1 row, 3 columns. The column is filled, the columns are filled with 0, 1, and 2. and then you can add 0, 1, and 2 to a 3 by 3 array filled with ones, and then you obtain the results shown here. NumPy hasn't been imported, so because I didn't start running it from the very beginning, I don't have NumPy installed. Now this will be unnecessary if I had run the previous cell that had NumPy imported. So that's your ones, that's your A range 3, and then you add them up element wise. That's what you get. This is your ones. You reshape 0, 1, 2 so that it becomes a column vector, and then you can add it because it broadcasts the 0, 1, 2 horizontally, and then it becomes 3 by 3, and you can add it to these ones like we showed earlier. We're able to slice NumPy arrays like I showed in class from lower to upper, right? That's what we've been working with. On the left side is the lower limit, upper limit is on the right side. But in NumPy arrays, you can also provide a third argument, which is the step or increment. So if by default it's 1, if you set it to 2, then it skips every other item. So this is your NumPy array 10, 11, 12, 13, and 14. We can ask for the index of the second element and the third element, right? 1 is not the first element. Indexing starts at 0. So this one actually refers to 11, 2 is 12, 3 is 13, but does it get to 13? No, because you stop 1 short of the element at index 3. This is the element at index 3, so we stop at 12. So basically you have 11 and 12. You start at 1, and then you start at 11. You stop short of the penultimate item. So this is -1. This is -2. So we don't get to -2, so we stop at 12. So it's 11 and 12. This and this yield the same output. This asks for everything, right? You don't provide the lower limit, you don't provide the upper limit. So it starts from the first item, ends at the last item. So that's 10 through 14, inclusive of 14. Here you start same as before, right? Except you have a third argument, which is 2, meaning skip every other item. So start at 10, skip 11, grab the 12th, skip 13, grab this. Those are the results when the code is run. And I'll continue this in the next video.